time to start this session, and I would like to wish you very welcome. This session is about circular economy, design for longevity. My name is Sophie Hallstedt. I'm a professor at Blekinge Institute of Technology in Sweden. I do research in sustainable product development, and I will support you in this session. So the first part is that we will remind everyone to please ask questions in the chat, and also please also write which paper you refer to when you write your questions. We have 5 papers in this session. We will present the authors in between the different presentations of the papers, we will start with Andreas, who will have a recorded presentation, and then after all the presentation have been presented, then we will open up for a question and answer session. And also, it's okay if you want to show your video audio when we have question and answer sessions. You're very welcome to also as participants then if you want to ask the questions yourself instead of me asking the questions. But we take that when we come to that session. So please now, I think it's ready to start the presentation sessions.
Hello, I'm Andreas, and I'm going to present our paper on how design consultancies have an inconvenient position in the supply chain when trying to push for longer-lasting products on the market. So throughout the presentation, I will be going through a quick introduction about our findings, the theoretical network that we based it on, how we applied our methodology, our analysis, and lastly, the discussion from the paper as well as the conclusion. In today's society, climate and conscious consumption is at the forefront to create a better world. At least that is the way that it should be moving forward. Many companies are striving to bring forward long-lasting products that will have a purpose and relevance for the year to come, and researchers has also already been working on it. This includes Cooper, Hertz, Lilly, and many more. However, bringing such products to the market is not always an easy task, and several barriers are present when attempting to create or push longer-lasting products onto the market. The article by Peter Jensen, Barriers to Product Longevity, a review of business product development and user perspective, is based on a thorough study of the literature works and covers the product longevity barriers in great detail, which is a big part of this article is based on. And even though Peter Jensen has tried to relate all barriers for making long-lasting products, we believe to have identified yet another one with data collected throughout a 4-month case study in a Danish design firm. We have found that it's especially difficult for design consultancies to be a forerunner and push for longer-lasting products on the market, especially because of their position in the supply chain. First of all, we needed a definition of long-lasting product, and we'll use the one from Peter Jensen's article, which is products that are durable and considered useful and desirable by the users for a long period of time, and at the same time provides a viable business. Furthermore, I'll just quickly run through the meaning of the before-mentioned 3 different categories of barriers that stands in the way for creating longer-lasting products. First of all, we have the business barriers, which can shortly be described as factors that demotivate the company from implementing strategies to extend the lifetime of their products. Meaning, if they don't clearly benefit from changing the company structure, they will probably not do it. Secondly, we have the development barriers, which is about the limitations in engineering a product to be more durable. And it obviously requires a different know-how in the development phase, but it's even more critical if the product is trend-based, which means that it will often lose its the desirability prematurely. And the last one is the usage barriers, which covers the barriers from the user's perspective. which it can be very difficult for the users to determine any given product's true durability and thereby the expected lifetime of the product, especially when you try to compare it to the price of the product. While working with these 3 different categories, the team found that it didn't include much information about what potential barriers there are when multiple companies have to collaborate. And it seemed like there were an increased complexity around the business and the development barriers, as design consultancies could be argued to be in between these 2 categories. So this study is mainly built on a 4-month case study where the research team collected unanticipated findings in combination with theoretical insights gained in the same time span. For all the interviews conducted during this time of this procedure were semi-structured interviews with a pre-made interview guide, as it was very important for us to get a fluent dialogue and a discussion with the interviewed in order to gain unexpected data. During the interviews and the 4-month case study, it became apparent that design consultancies might suffer from a misalignment with their clients in aspects of wanting to design long-lasting products. As the interviews were transcribed and the insights were collected, the team were able to define 16 findings or insights, and these were sorted into 4 different categories, with the most prominent being which barriers are there in product design consultancies when you want to push for longer lasting products. So the team identified 3 different problems when analyzing the insights covered by the before-mentioned categories, and I'll just quickly go through them. The first one being when the design company or the case company submits their design to a client, they're no longer in control of the product, including how it's manufactured. And this might seem obvious, but it can be even more difficult when starting new collaborations with new clients to understand how they see craftsmanship and what they see as proper materials. For the second problem, more often than not, it seems like the competition on price is so violent that it overshadows the sustainable aspect of a product if longevity is not a core part of the client's vision. And thirdly, getting new clients that follow your own vision can be very difficult, which is why the case company sometimes has to work with clients that do not follow their own understanding of responsible design, just to gain funds to be financially stable. When we are talking about the design consultancies conceptualizing a long-lasting product for a client, they have to comply with the client's value chain, which is considered a development barrier, as it's challenging for a company to try and fit this already developed infrastructure. But considering the relationship between the design consultancy and their client, the responsibility for realizing the product to be long-lasting is the client's. This indicates the relevance for the business barriers, as it's often very costly for any company to make a significant shift in their existing business model. This alignment between the companies therefore have a huge impact on the collaboration, of course, but it also greatly impacts the design consultancy's ability to make sure that the products they get onto the market are in fact longer lasting. Through this, the team found that the literature review done by Peter Jensen doesn't take into consideration collaborations. We therefore propose a new barrier, the collaboration barrier, as all 3 of our analyzed problems fit into this category. But keep in mind that this study is only based on a very small data set, and we would therefore like to extend the study to include additional and more diverse design consultancies, as well as analyzing different aspects of the value chain to see if the problem affects any other parts. And that's everything for me. Hope you find the study interesting.
Thank you very much. And that was the presentation from Andreas Fenger Bendixen, and Andreas is a research assistant at based on Aalborg University in Denmark. A next paper that will be presented by Margherita Tufarelli, and she's a PhD researcher in design at the University of Florence in Italy. And I will also just remind everyone to please put your questions into the chat. Thank you.
Sustainable transition requires multidimensional transformation of socio-technical systems towards a more sustainable models of production and consumption. The theme of sustainable transition is one of the great challenges of our time and involves almost all sectors of human production and consumption. One of all is fashion. that has long been confronted with a layered problem regarding sustainability that involves design, production processes, distribution, and the wider dynamics of consumption. This research aims to investigate the role that slow fashion currently plays in contrast to the fast fashion system, focusing on the responsibility that design can have, helped by digital technologies, for the development of future solutions in the sustainable field. With the industrial age, become a decline phase in uses and abuses of natural resources. The Industrial Revolution drastically changed modern society in function. This growing need for industrialization, characterized by faster production and larger quantity of materials, began to spread through the world, growing exponentially in an interconnected globalized network of the fashion system. The fashion system is often marked by processes significantly impacting the environment, especially in terms of consumption of natural resources, use of chemicals, and consumption of electricity. The fashion industry turns out to be one of the most polluting industries in the world, with a huge environmental, social, and economic impact. This means that sustainability in fashion is a layered problem. That means that the problems are in environmental change, renewable energy, materials, clean water, clean technology, circular economy, production processes, and so on. Above all, we understood we went too far. Our reckless action have burned the house we live in, said Alessandro Michele, the creative director of Gucci, in 2020. This means that the environmental problems is complicated by the issue of transportation and production of semi-finished product, which add to the release of various chemicals into streams and rivers, creating serious health problems, as well as soil infertility, deforestation, and environmental deconstruction. We know that fashion is a commercial industry that produces and sells material goods. Fashion also contains an immaterial system of meaning made up of individual and collective signs, which merge through practice of production, consumption, distribution, and representation. The entire fashion system is an industry governed by a strong drive for change, where each individual turns out to be emotionally and culturally attached to clothes. Sustainability in fashion is difficult to achieve due to the complexity of the entire supply chain, from fiber cultivation to weaving to tailoring retail practice. Each step is exposed to significant risks. Moreover, the fast fashion phenomenon has led to a disposable culture in which fashion is bought, worn, and discarded very, very quickly. Lead times for these items are very short, and items are constantly being replaced to keep up with fast-changing trends. This results in an increased fashion waste and resource consumption. But nowadays, we are facing the emergence of a responsible consumer that will irreversibly fuel demand for products with sustainable characteristics. Consumers are now aware that, in addition to labor rights and common environmental issues, sustainability of garments depends on several factors, such as fiber, yarns, dyeing processes, and transportation, for example. Therefore, sustainability cannot be about the fast fashion system, which is quantity-oriented, leaving aside quality, that is increasingly cumbersome on the global stage. Buying less while maintaining high quality can be a possible solution. Future paths for reaching sustainability in the fashion system could be the return to a slow fashion, increasing the consumer awareness to change the consumption pattern used so far, but also in the innovation and in a multidimensional approach, providing the opening of spaces in society for a change in values. This means, more than anything else, a new ethical cultural orientation. Technology and industrial revolution tends to rapidly transform production and society. Digital innovation with Industry 4.0 and ready to welcome the new challenges of the super smart society 5.0 constitutes enormous potential. Digital technology can contribute to the sustainable transition with the innovation of digital devices in digital garments and clothes and wearable technologies, in the optimization of design and production phases, in time and in use of materials, in communication, in traceability, and in transparency. The innovation given by enabling technology will bring new manufacturing processes in fashion and textile, which will probably generate a new paradigm of production and consumption. Then the future of sustainability is inclusive. Fashion must give priority not only to the planet, but also to people that live in it. The digital revolution, flanked by a production towards the no size, no gender, and no season market, will bring a substantial challenge in the change in the fashion system, allowing to buy only the garment that will actually be ordered, thus limiting the production choices. The future probably goes towards an adaptive clothing that, lasting over time, adapts to the change of the body in the different phases of life. Designers in this scenario have a great responsibility that looks more like a challenge. They should design products with a strong technological innovation, characterized by an expressive formal and aesthetic charm, recyclable, reusable, easy disassembled and disposable product. Designers should create products that are also durable, desirable, and at the same time to create profit, able to create profit. That means that great challenges are yet to come, and radical vision of the future are needed to help launch change and foster a revolutionary transformation of the relationship between fashion, consumption, technology, and the environment.
Yes, thank you. That was the second paper. And the third paper with the title Products That Age With Us, Carpet in the Turkish Household will be presented by Rengin Gurel. And she's a research assistant at Fatih Sultan Mehmet Vakif University in Turkey. So please.
Greetings everyone. Today I will be presenting our work called Products That Age With Us, Carpet in a Turkish Household. My name is Rengin Gurel and we conducted this study with my supervisor, Ozge Celikoglu. This presentation will cover the theoretical perspective of the research, the fieldwork and study, our findings, and before I conclude, I will mention potential design implications. This study explores carpet, which is an intergenerational product in Turkey that lives and ages with its users. Because carpet is something that is passed on and it is given as marriage and home gifts, we aim to understand why it matters and stays in Turkish homes. This paper argues that products have life cycles, just like human beings. They are born, they live, and then die. But they spend most of their life being used. Understanding a product's life, especially when they are being used, can tell us much more about the people that utilize them and the setting they belong to. Investigating the products that age with its users have the potential to identify why a product matters, what it signifies, and the traits that make them emotionally durable. To understand carpet's significance, one needs to understand its users and its context. Using ethnographic methods is valuable as it enables researchers to learn about the thing with people and the setting. To make sense of carpet, an ethnographic study was conducted through participant observation and in-depth interviews. Participants of the study were between the ages of 25 and 53. All of them could be considered middle class in Turkey. Interview questions were mostly open-ended and they were about the meaning of carpet and carpet's relationship to its user, space, and other objects. The fieldwork revealed that there are two main concepts that explain carpet's meaning. Its material culture, which explains why carpet matters, and its signification, what does carpet signify? Understanding these concepts revealed that carpet is an emotionally durable product in Turkish homes, and this is related to its intergenerational quality. And our findings are explained with these two concepts. Why does carpet matter? Firstly, carpet signifies its user and has socializing traits that make it important in its societal context. It differentiates and integrates its users with their community. Moreover, artifacts carry representations of cultures they belong to, which include the way society lives and things they appreciate. Objects indicate the identities of their users, and they are messages of the society that made them. Secondly, carpet, especially when handmade, is a product of labor, and regardless of its production method, carpet needs care and maintenance to keep it alive. One needs to clean, groom, and take care of it so it can be used for longer. This maintenance could be keeping them clean, repairing them, making them look right by combing their fringes, and more. Carpets are physically durable and long-living. Also, when users spend time and energy maintaining their carpets, an emotional bond could form between them. Secondly, carpet signifies home and its user. Carpet gives warmth and therefore makes a house home. It makes the ground a place to sit comfortably, and it has connotations to their weavers, Anatolian women. Therefore, carpet is a consistent signifier of home in Turkish culture. For many Turkish people, if a house does not have any carpets, it does not feel like home. On the other hand, carpet becomes a signifier of self, self meaning the user. Carpet signifies the user's character, aesthetic views, financial status, and stage in life. In this research, we argue that user narratives are valuable since they enlighten designers and researchers about the unseen part of the design process, the use. Designer designs a product, it reaches to its users, and designer does not always see the next stage. User narratives give user a voice, and researchers can analyze them to provide design suggestions. In the scope of this study, user narratives were examined to give design recommendations. Results of the research suggest three main design considerations for making long-living and emotionally durable products. Firstly, designing products that can be maintained. Secondly, designing products that relate to its space. And finally, designing products that create emotional bonds. Findings suggest that products should be designed in a way that users can maintain or take care of it, so a user-product bond can occur. Secondly, designing products that relate to its space is an important factor for prolonging its use, since products may become representations of their space. In the case of carpet, it is the maker of home. Designers should design products that relate to its space in a meaningful way, so it can live longer within its space with its user. Product-user relationship and potential emotional bonds should be considered when designing long-living products. Designers should consider how their designs will be representing the users and how it could differentiate or integrate them. To conclude, examining a product's importance and emotional durability can enable new understandings of product meaning and sustainability. Here are my references, and I would like to further elaborate if you have any questions. And you can reach me via this email address. Thank you for listening.
Yes, thank you very much, Rengin. And that was the third paper. The fourth paper is from Vishal Srivastava, working as a Prime Minister Research Fellow at the Department of Design at the Indian Institute of Technology in Delhi. And his paper is about parameters proposed for sustainability assessment of biocomposite-based rigid packaging.
A very good afternoon, everyone. My name is Vishal Srivastava, and I am a PhD research scholar from Department of Design at IIT Delhi, India. And my supervisors are Professor Sumer Singh from Department of Design and Professor Dipayan from Department of Textile and Fiber Engineering. And my topic in presentation is parameter proposed for assessment of sustainable biocomposite based rigid packaging. So I will start with a brief introduction of packaging. So rigid packaging is a type of packaging that provide higher protection factor with compared to other types of packaging, and it is usually made of stronger material like glass, metal, and rigid plastic. And if we talk about the framework can be defined as a set of rules, guidelines that we use to solve the problem or make some decisions. And fiber reinforced biocomposite is a kind of composite in which the fiber are used as a reinforcing phase and biopolymer used as a matrix phase. If we talk about the application of rigid packaging, as we can see in the picture that there is like pharmaceutical bottles are there, food and beverages bottles are there, and cosmetic packagings are there. If we talk about the limitations, so rigid packaging create a lot of environmental impact in terms of air pollution, water pollution, landfill problem, etc. So natural fiber reinforced biocomposite can be alternative solution, because we have already discussed about conventional packaging materials limitations in terms of they are made from non-renewable resources, having higher environmental impact, creating public health problems, and required higher energy to produce. In literature, it was found that natural fiber reinforced biocomposite have less environmental impact than conventional packaging materials because biocomposite is made from natural resources like natural fibers and biopolymers. And these materials have advantages in terms of they are made from renewable resources, having higher mechanical or specific strength, creating less environmental impact in terms of pollution, or having low cost. So biopolymers made from these two materials having same advantages. So what is the need of framework? With the help of framework, manufacturer companies, designers will select and compare the biocomposite based material for development of rigid packaging. But the problem is existing frameworks related to packaging sustainability have some limitations. For example, they have made for some specific application, for example, for food prevention or predicting the purchase intention of consumers, or it consider only few aspects of sustainability, or have some limited step of package life cycle, or it consider like few parameters while assessing the environmental impact assessment. So why the new list of parameters are required? Actually, conventional packaging materials and bio-based packaging materials manufacturing is totally different. Conventional packaging materials come from crude oil distillation. This process is very energy intensive and create a lot of air pollution. So in this case, energy used and pollutant released during manufacturing is very important. In case of bio-based packaging materials come from harvesting and cultivation. So harvesting and cultivation require a lot of water and also create a lot of waste. So in this case, water used and waste generation is very important for consideration. If we talk about life cycle stages of fiber reinforced biocomposite in packaging application, so based on literature, it is divided into 5 parts. First is harvesting and cultivation. Second is pre-production of fiber or biopolymers. Third is biocomposite packaging manufacturing. Fourth is product packaging and consumptions. And fifth is end of life. And right side, we can see the flow diagram from starting from cultivation of fiber to end of life of package. Sustainability assessment parameters are broadly classified into 2 aspects. First is environmental, second is economical, performance and functional parameters. In next few slides, the list of assessment parameters is given based on biocomposite life cycle phase. In harvesting and cultivation of the crop phase, the environmental parameters are waste generation, energy consumptions, land use, freshwater consumptions, total pollution, air, water, land, effect of use of fertilizer on environment. And in terms of economical performance and functional parameters, the quality of yield, for example, if the better quality of yield will be there, so then quality of final biocomposite will be better. The requirement of human resources and machineries, and cultivation cost, soil quality, crop efficiency, crop cycle timing. So these parameters affect the economical performance and functional parameters. In pre-production phase, a lot of machineries and chemical are required to extract the materials, and in so environmental parameters include hazardous chemicals, material used, and total energy required, total process water used, and total waste generation and total pollution emission. And in terms of economical performance and functional parameters like transportation cost, process cost, shelf life of raw materials, and quality of raw materials, number of processes, and machine efficiencies are the parameters that can be considered. In biocomposite packaging manufacturing, environmental parameters such as material use, energy used, waste generation, hazardous chemical required, and pollutant release are similar as pre-production. And in terms of economical performance and functional parameters, in this case, properties are plays an important role like physical properties, mechanical properties, barrier properties, transportation cost, and machine efficiency. That parameters are very important to consider for assessment of sustainability. In product packaging and consumption part, the environmental parameters like waste generation, energy required, material used, pollution release, and average life, energy source are parameters. And in terms of economical performance and functional parameter, so it include like pack size, shelf life, aesthetic, is the protection factor, transportation cost, ratio of product volume to package volume are very important. So end of life phase, environmental parameters such as like energy required, biodegradation time, incineration with energy recovery, home composting or industrial composting, pollution release during these. And in terms of economical performance, functional parameters like how easy to unpack the product from packaging, waste cost, percentage of materials. So these are the important parameters that we have to include during assessment of bio-based rigid packaging. So now we can conclude as fiber-based biocomposite are eco-friendly in nature and have better functional properties. Biocomposite-based packaging has slightly different scenario as we have earlier discussed as a manufacturing level, and proposed parameter can be used in sustainability assessment of the biocomposite-based packaging. So proposed parameter uh, can be used in a framework that can offer manufacturer, designers, or engineers for designing and development of sustainable rigid packaging. And these are the references that I have cited for making this presentation. And thank you so much for your attention.
Thank you very much. So that was the fourth paper. Now we are into the last and fifth paper, which is written by Julia Mettik, which will be one of the presenters. She's a PhD student at the Technical University of Denmark. And also we have Svenja Close, which is a PhD candidate at Technical University of Munich. So please, the paper is a proposal of a dual circularity concept for sustainable design.
Welcome. Our paper proposes dual circularity concept for sustainable design. Current circular economy approach in theory does not explicitly consider the interconnectedness of biological and technological cycles. In practice, many bio-based materials enter technological cycle, such as wood and paper, while organic and inorganic elements are either integrated into resources naturally or designed in. Moreover, important to mention is that the new Circular Economy Action Plan aims to promote bio-based, biodegradable, and compostable materials for better environmental benefit and to reduce use of fossil fuels. Therefore, without considering the mentioned dynamic links between two cycles, there is a risk of neglecting the advantage of using and recovering value of resources at the end of the use. Further, choosing which loop to follow and how to transition between one loop paradigm to another with perspective of both cycles could help companies to avoid loss of value of resources as long as possible. Moreover, it could help to influence the overall sustainability performance of circular system, which is why we propose dual circularity approach.
The two research questions you see here guided us through the development of a dual circularity definition. The first one targets at the comprehensiveness of the circular economy concept. The second one focuses on the requirement that the dual circularity concept should be helpful to practitioners. To address both questions, we first performed a state-of-the-art review. The review contains the evolution of circular economy concepts and identifies gaps that served as the basis for our dual circularity definition. To develop that definition, we established three criteria. First, the new dual circularity concept should be linked to the already existing circular economy concepts. Second, the developed definition should be helpful. And third, dual circularity should increase the number of alternatives available during the process of deciding for a most sustainable alternative. Finally, we developed 3 examples to test, adjust, and illustrate our definition.
The concept of circular economy has been well researched since it became popularized in the 90s. Evidence of the origin can be specifically traced since multiple contributors and approaches inspired the concept, as seen in the figure. But commonality found is that they share a similar line of thought, one of closing the loops. Moreover, all of the concepts except permaculture focus on both cycles in one way or another. As an imperative, those different concepts contributed to the variety of circular economy definitions, but as mentioned, with focus on a differentiation between the cycles. The table presents what aspects are represented in circular economy concept today by available definitions, using examples, and in the empty boxes what aspects are not explicitly acknowledged, which means that bio-based materials or products are always designed and directed to end up in biological cycle, while technological and mixed are always directed to end up in technological, which potentially overlooks the contribution of improving the circularity and overall environmental performance. That one of technological aspects of renewable materials can have, as well as certain materials of technological origin directed to biological cycle when recycling is not an option.
Based on the aforementioned considerations, we developed the following dual circularity definition. Dual circularity is a holistic approach. We refer to it as holistic because the concept includes aspects that we found were missing in the existing circular economy concepts. Those aspects now build the core of our definition, and that is the fact that dual circularity does not only include biological and technological cycles, but that it also considers the possibility that materials and products can switch these cycles. Being aware of that possibility is particularly important in the design phase, where the designer has a comparatively great leverage to impact the sustainability performance of the design object. Eventually, the overall goal of dual circularity is enhanced sustainability performance of the entire system.
Next, several examples are used based on the material origin and end-of-life cycle options to identify any logical contradictions when the dual circularity approach is applied to real scenarios. The green fiber bottle is biological origin, designed to be looped several times and circulated between cycles, with primary choice of cycle as technological. When the recycling is not an option anymore, the bottle is planned to end up in biological cycle. The fossil-based compostable plastic packaging, even with technological origin, can follow the similar pathway as previous example. And in the example of Tetra Pak with mixed materials, the choice of cycle will depend on the type of material and its quality and quantity, with goal again to retain the value as long as possible.
Before we conclude, I would like to highlight a few points. First, we do not evaluate the concept in comparison to existing concepts. It is not better or worse. Instead, it introduces yet another focus on circularity with the intention to support practitioners in the design phase. Second, one goal of the dual circularity concept is to be generally applicable and holistic. This, however, comes at the risk that some special case considerations are not covered by the concept. In addition, the concept can increase the number of sustainability options to choose from. However, the concept is not a tool to identify the most sustainable solution. For that, methods such as life cycle assessment, for instance, are still required. And lastly, the field develops fast. Consequently, dual circularity may be one further step in the evolution of circular economy definitions, yet it very likely is not the last one. To sum it up, dual circularity is an expansion of the existing circular economy understanding. It includes both biological and technological cycles and emphasizes the possibility of products and materials to switch cycles. By doing so, the number of design alternatives to choose from can be increased. To illustrate the concept, we provided 3 examples. One contribution of the dual circularity concept can be to serve as a basis for the development of a framework. Such a framework may include specific guidelines for practitioners or enable the identification and mitigation of potential trade-offs and rebound effects.
Thank you. And that was the last paper presentation. Now we go into the question and answer session, and we have got really good questions here. Just to check before we continue is to see if we have Margherita Tufarelli in the audience, or if in that case, if you can show your audio, open up the camera and show and audio.
No, she didn't join.
Okay, so in that case, we will not take those questions that are from Margherita, of course. But let's start with the questions that we have for Andreas, and then we see if Margherita shows up. I think that it would be nice, actually, if the persons that have asked the questions would like to ask the questions themselves and open up the camera and do it. Otherwise, I will do it for you. But I know I have questions from Tim McAloon, questions also from Rengin, who is already here, and Julia and Svenja. So maybe you can start, Tim, if you're here. You're very welcome to ask the question yourself. Okay, I cannot see. Is that possible, Robert, to
Yes.
allow several to talk?
Yeah, Mr. McAloon, please refresh your page. I approached you,
Yeah.
but
Okay.
your video, I think you need to just refresh the page.
So maybe we can start with Rengin, if you would like to ask your question, because I know you're here. Now you're muted, Rengin. Okay, I think I can read the questions then. No problem. So I start with the team's question. Did you explore differentiate the barriers for design of longer lasting products, design for longevity, versus barriers to actual longevity in the market? That is the first question. So maybe you would like to start with that, Andreas.
Yeah, thank you for the questions. We didn't look that much into the products with the longevity already in the DNA. We were more looking at what is holding back companies for designing and planning for longevity in the products. We ended up with a design consultancy because that's what we had at hand, where we could gain the best information, and found that it didn't fit into the model that we were already looking at concerning the business usage and development barriers that were already identified. So the interesting question for us came up with: how is this affecting a company that is in between manufacturing and designing and using? So we found there are some relations that haven't been explored yet. And we were mostly looking at like their vision for improving the longevity of their products. We haven't analyzed any existing products for their longevity.
Thank you. I think, I mean, it's very interesting, I think, to study that when you have different roles and different types of companies in the value chain for circularity, as you have done, and studied specifically for consultancy, because there are so many consultancies involved for many companies. And there is a question here from Rengin asking about, after conducting this research, do you have any ideas how to break these barriers, how to mitigate those? Did you come up during your interviews or anything? Can you see how you can mitigate those barriers?
Yeah, we were not looking for how to break down the different barriers. We were more trying to identify them and to explore them. But it definitely came up as something that you should note you should have a lot of focus on when trying to cooperate with two different companies, where some of them are the client and some of them are the designer. So in the future, people should be more aware of aligning with the companies that they're working with, and not only looking at the portfolios to see if they align with those, because they are not always one-to-one with all the products that they produce. We found that some design consultancies hide some of their products from their portfolio because it's not something they're proud of. So putting more energy into aligning from the start is an important goal for both companies, but it's not always that much of a focus. But it might also be a thing where there are more design consultancies that are looking for making longevity while their clients are not. I think it's balanced in that way.
Thank you. And maybe we can jump to Svenja's question, which is a little bit different. I don't know if you want to ask them yourself because you are here. We can test your mic at the same time.
Yes, sure.
Yeah, okay, yes.
Perfect, nice. Thank you. Yeah, thank you again for the nice presentation. I was wondering a bit about the maybe heterogeneity of the answers that you got from the interviews. You yourself did mention in the end that you would like to have an increased number of interviews to base your results on. And I was wondering if your results would maybe change a lot, if you could even come up with further categories of barriers. Yeah, what are your expectations in that regard?
Yeah, hopefully we'll be able to talk with more diverse companies from the get-go, because this company we're doing interior products and furniture, and that goes well with Julia's question, where I think it has a big impact on how these companies should align with their visions, depending on what product they are making. So for the interior and the furniture, of course, there's a big visual impact of the products, and that's often where they get obsolete because the trends shifts. But if we look at other design consultancies, maybe they're doing electronics instead. They have to work differently, because then we are looking at planned obsolescence with if something is wireless, for example, which technology are you using for making the product wireless. So the focus for both companies are different depending on what market they're in. But we would also like to look at the companies in different sizes and see if they cope with this differently in different companies.
Thank you. And also thank you for lifting up the question Julia had. Julia, do you want to complement your question, or did you think you got an answer to it?
Yeah, I think the questions were kind of connected, so I got an answer completely. Thank you.
Okay, thank you. Then if Margherita is not here yet, we move to the third presentation, Rengin.
Yes.
And here we have also 4 questions from, we have from Jeremy, we have from Svenja, Mark, and Tim. So if you like, you are welcome to ask your question.
Cool. And is my microphone working?
Yes, good.
Great. So I liked your case study of a product that already exists where the culture really drives the slow consumption rather than fast consumption, particularly of textiles like the fast fashion presentation. And I'm wondering how much of that slowness historically speaking, is due to the design factors that you mentioned versus just the sheer cost of these carpets, because these are expensive things. And that's, I guess, my first question. And then my second question is, do you have more concrete suggestions for your design recommendations for other products that are not carpets, to whether they're culturally specific things in Turkey to drive slow consumption, or that would be specific to other places?
Thank you so much for the question. I think the historical background is obviously a big part of it, because carpets have been a part of Turkish homes for a long time. But I think what was interesting about this research was that users that did not have handmade carpets, they also used them for a long time. And those ones are also passed on from generation to generation. So when you come to Turkey, I think most of the houses would have carpets, but they are not especially handmade. Most of them are nowadays manufactured, but the ones that are in good quality are also quite long living. So I think the product's quality also plays a big part, since it really lasts long, but also it has a big history behind it. And it is given as bridal chest gifts, and it is given to kids when they move to their homes as well. So I hope that answers your first question. And for the second question, I think it needs further research to maybe make specific suggestions to other product categories, because we tried to keep them a bit more general so they could be applicable to other cases. But the example that came to my mind is, for example, I have friends that have PC computers, and they clean them, they change its pieces, and it just becomes a thing for them to use for a really long time. And I think the maintenance and care is a big part that makes the emotional bond between the product and the user. So I think that could be applicable to many categories in terms of its design. I hope it answers your second question. Thank you.
Thanks.
Thank you very much. We have Svenja here as well. Do you think your question is, do you want to ask and complement with the question?
Sure, why not? Thank you also from my side for the presentation. It was very interesting. It points a bit into a similar direction as the question before. I was wondering what types of products or product groups do you think your research is most relevant for and could maybe have an impact there?
Yes, thank you so much. I think I can connect it from the first answer as well. I think even though it may look unrelated, electronics could be actually designed in a way that users can maintain them and take care of them, so that they could be used for longer. Because nowadays, like fast fashion, I think we have a really fast electronics business that we keep buying the new model because the other things doesn't fit the earlier model. All of the applications change, all of the use change. So if that could be something that we could maybe take care of and change, for example, we could change its pieces, its own application systems, maybe that would be helpful to make them more long living. But I also know that industry doesn't want that to happen, because then we won't buy anything. But that's what came to my mind. But I think it could be a good point to further this research, to look into other product categories and to see if we can applicate these suggestions specifically to them. Thank you.
Thank you. And I think also we have Mark here that have a question to you. So please, Mark.
Hello, yeah, thank you very much for the presentation. I suppose I was watching, I wondered if you thought that the design of long-lasting products is easier when there are fewer design solutions to a given problem. So I suppose in the link to the presentation too, which is about fast fashion, obviously there's, I don't know, hundreds of different types of clothes, and there's loads of different varieties of things people could have, and so they want a lot, whereas relatively carpets, there'll be much fewer options. And then I wondered if that linked to a more general point that perhaps we could consider this idea of having choice of products being the enemy of sustainability, and whether you agreed with that or not.
I think it could be. Your question left me quite puzzled to think it in a broader sense. I think, for example, if I talk about carpet and then maybe furniture, when you buy a carpet in Turkey, for example, or buy a furniture in anywhere else, you most probably think through and change your options according to your home, your budget, and it's a really time-consuming discussion with your head. But in fast fashion and in clothes, it became more of a quick decision to us. It's like we need it because we will wear it, we buy it, and it wears out because it's not in good quality anymore. Then we buy another one, and there's also a fashion that makes it stronger for us to buy them more. So I think a lot of factors play into this, but the fewer options could make it more long lasting, especially when we think it with the budget as well. Those were the things that came to my mind. Thank you for your question. I hope I answered it.
Thank you. And also Tim has a question here, please.
Yeah, and I hope you can hear me now.
Yes.
Both because of the microphone and also because of the thunder outside. So I've basically asked exactly the same question as the other three questioners, but if I could, pretty much at least, but if I could maybe go a little bit further and say, what about the characteristics? I think that was both what Jeremy and Svenja and Mark were asking. Are there any particular characteristics that we can draw out of your case and make broader? It would be quite nice to see what can we learn across different product types. But I think you've answered slightly that question already.
Yeah, I tried to. I hope I could. But another thing that maybe I could give an example as that some of the carpets in Turkey that are handmade, they are actually becoming in a better situation as much as you use them. So the colors and the texture and its brightness changes as long as you use it. So I think that's where I made the connection with emotional durability as well, because in his book, Chapman also gives examples that products that change with time, with use, but it changes into something that is designed. It changes into something that user can still benefit and bond with it. So I think maybe the design process could think of that, can think of the product's life cycle as a whole user experience, rather than it just becomes broken or it becomes obsolete. It can change into something that is maybe not better or worse, but in a different version. So maybe we can eliminate the fast situation with that.
Yeah, if I could maybe follow up just briefly on that, Sophie. I think one of the interesting things when I collaborate with companies and help them and guide them to do sustainable design or design for sustainability, quite often you get the product developers and the engineers in the room, and they understand design for material efficiency. They understand design for remanufacture. They understand design for disassembly and so forth. But then if you put something on saying design for timeless design or design for emotion, they have no clue what the hell you mean, and it ends up getting pushed back to the end because it sort of somehow is at a very, very different level, and maybe it's different people in the organization that actually are designing this. How do we bring the design for longevity, really important points you mentioned, up to the fore and up to a level where the everyday product developer understands them as well and knows how to design both for materials efficiency but also for emotional connectedness and for beauty and longevity and so forth.
Thank you very much, Tim, also for this comment. And we move forward to the next presenter, which will be Vishal Srivastava. And we have a few questions to you as well. And here we have already Jeremy and Julia on the stage, so to say. So maybe you would like to ask your question, Jeremy.
Sure. Yeah, I think we need more people looking at biocomposites like you are, definitely. I'm wondering, I couldn't quite tell from from your presentation, are the matrix materials that you're looking at, are they all thermoplastics, but biological ones that have to be melted to produce parts? And if so, have you explored other kinds of materials that don't require so much energy use during the processing of the manufacturing? Or are the materials that you're looking at more epoxies, in which case there's very often toxicity concerns with epoxies, even if they are bio-based? And I'm wondering if you have improvements to suggest there.
Yeah, thank you for the question, suggestion. Sir, actually, in my case, the boundary condition is we consider only matrix or reinforcing material is totally bio-based. It can be bio-based epoxy also, but in if we talk about the manufacturing techniques like compression molding, injection molding, there's a lot of heat and energy required, process required. So in that case, we are developing a framework. So in that case, expert will suggest the weightage of that factor is more. So that will be covered in that part if we calculate the weightage. And next is less energy and the more energy is will be the bracket area is 100 to 200 is 1, 200 to 300 2. So that will multiply with the weightage. So then that factor will emphasize. In case of toxicity, I will definitely consider it in our parameter list. Yeah.
Okay, thanks.
Thank you, sir.
Thank you. And Julia, you had a question as well, if you want to ask.
Yeah, maybe I can clarify a little bit what I was thinking by this question, because I see now it's not so clear. It's mostly connected with our dual circularity definition. Basically, you state in end of the life option, you have energy for reuse, recycling, and then that's like an environmental parameter. Then you have economical and other ones for kind of disassembly of the packaging and etc. But I was wondering would you consider having those materials being recycled, reused before being composted or biodegraded? Would there be any different parameters that you could be considering as well? Because of course materials then would be degraded to some certain level or percentage. So would that change anything with your parameters?
Like in case of the environmental parameters, I have considered energy required to reuse, recycle, or recover. Or another parameter is it is biocompostable or not. If it is not biocompostable, then it will be definitely go for recycling, reuse, or some other applications or if it is biodegradable, then it will be the weightage of that parameters will be different. If maybe 1.5. So if we calculate the overall sustainability, that will be definitely cover in these 5 parameters of environmental parameters, like energy required to reuse, recycle, biodegradable or not. If it is used for some other application like for incineration with energy recovery, home composting, or pollution release in these factors. So definitely, I think most of the part will be covered in this.
Yeah, I'm thinking, so basically if you would have that certain material recirculating a couple of times in technical cycle, would that sustainability parameter be higher or lower, or how would that be addressed?
Yeah, but basically it is bio-based material, and bio-based material is basically we are focusing on one-time use material, the disposable material. So our focus is we can replace this food packaging or different, which is used only one time. So it's maybe used for second and third time, but our primary focus is to use for one-time use. And
thank you.
Yeah, thank you.
Thank you very much. And we move over to the last, I think, paper as well. So we have time for questions as well for Svenja and Julia. And then maybe I can start to ask a question here. because I think it's very interesting to see those two loops together, like a dual loop system. And as there is an interrelationship between the natural system and the social system or the society, I wonder, and you have looked into bio and techno, did you consider, or have you considered, or will you consider maybe how to bring in the social system in this? Because if you think about rebound effect and some of the, like the human behavior perspective comes in there more in the social part. Have you considered and thought about that?
Actually, that was a kind of our whole concept based on the human perspective of reusable packaging. So basically, the Carlsberg paper bottle was an experiment at DTU, where a couple of students divided a few of types of bottles to people, and the Carlsberg bottle didn't have any marking except it stated that it's biodegradable. So what happened in the end, that other ones were glass, I think, and metal, and they had bins where to put those bottles. So basically, experiments showed that people actually didn't care, that cared more about the glass and metal bottles being separated than actually biodegradable. So they were actually thrown much more into the nature. So with that concept, we were focusing how to make that more explicit for the design, also for consumers and producers, to have that in mind for end of the life when designing a product that can be actually circulating much longer in the system before being thrown back to the nature if it's a bio-based concept.
Thank you.
So yes.
Yes. Svenja, do you want to add anything there or no?
Yes, maybe I can add something to that, because the question you point to is actually a part of our definition in the last part of the definition, where we say targeted at the enhanced overall sustainability performance of the system. And their sustainability can, of course, be measured in many different ways. And of course, the social pillar is a very important part of it. So I think that's how we try to address the social aspect as well with that concept.
Thank you. We also have an interesting, inspiring question here from Tim. Tim, maybe you want to ask the question yourself.
It's more to tease the discussion. I'm one of the co-authors, so it's a bit unfair. But the question could be maybe rhetorical, but maybe Sven, you can answer it from a bio perspective, and Julia from a techno perspective. Will design for longevity actually matter once your PhDs are finished? Because we just basically decide the solution depending on the product usage, and it can either biodegrade or we reuse it, or what?
Maybe I start with the bio perspective. Thank you for the question. Yes, so far, if we just think of the biological realm and the biological cycle, then it's very tempting to just design a product which is bio-based and then biodegradable, and that's it. But with dual circularity, we have yet another option there. We can have a bio-based product, which is then kept in technological cycles for as long as possible, reusing it. And that would, definitely address the longevity aspect here. And as we know, maybe from the research, is that reuse is a very attractive approach in terms of environmental impacts. And after these technological cycles or loops that we have in the technological cycle, we can then return back to the biosphere. Thus, we have this combination of advantages that we can draw from both cycles there, from the biological and the technological cycle. And this definitely matters also from the biological or the bio perspective.
Yes, I would agree as well. For technological cycle, it is still important, especially because we want to keep those materials for as long as possible in the technical cycle, which means they need to be some kind of a design for longevity. So the material aspect and the percentage of the material and the quality should still be to a certain level. And of course, we never can have one-to-one replacement. in that case, it is really important to have really quality materials that can be reused, recycled, etc. So the primary resources are used less and less.
Thank you. Thank you. A question here also from my side. I was curious about the next step for your research. What would that be?
For me personally, for instance, I'm currently working in a project where all those considerations are extremely helpful at the moment. Being aware of all the cycles and loops that can be chosen, and also the combinations of them, and that is actually combined with also life cycle assessment to actually see which alternatives are the most sustainable ones. As we stated in the presentation, that's not what our concept offers. It does not select the most environmentally friendly alternative. It only widens the perspective on different alternatives to choose from in terms of sustainability. And so the next step can be to use this concept in a real setting, and then also see what kinds of implications that has for design alternative choices.
Thank you.
And considering my part, I would mostly focus on kind of pre-implementation of any kind of circular strategies for a product, and considering which first loop to choose or which cycle to choose in a decision-making support tool. I would kind of analyze what would be those rebound effects that could possibly happen and how they can be avoided or kind of less stressed in a certain case of a company.
Very interesting. Thank you. And we also maybe should have the last question here from our moderator. Maybe you would like to ask a question as well.
Oh, yeah, I'm just interested. Have you performed a case study or some sort of research on your said examples of bottles or Tetra Paks, and how do you track the number of life cycles that product can withstand? And have you maybe consider in future work how to gather that data and perform some sort of data analysis?
Thank you for your question. I think that points to a very interesting part and very important part. Our concept tries to be very holistic and broad, and to offer the basis for answering such questions. And I think answering a question that is just the next step.
Okay, thank you.
Thank you.
Thank you very much. So now it's time. It's only a few seconds left on this session, and then it's continuous conference. So I would like to thank you very much, all of you, specifically the presenters, and also the audience that you could come up to stage and have this interesting discussion. And I also want to thank the moderator for supporting us in this session. So bye-bye, and good luck on the rest of the conference. Bye-bye.
Thank you.
Thank you. Goodbye.
Thank you.